In this lesson, we will use the Address Resolution Protocol, ARP, to assess organizational security. We are in the ARP portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the operations and incident response section of the exam. So what is the Address Resolution Protocol? The ARP protocol command in Linux is a network utility used to display or manipulate the system's ARP cache. Network administrators, system administrators, or users with appropriate permissions can use the ARP command. The ARP command can be used whenever there is a need to view or modify the ARP cache on a Linux system. The ARP command is used in a Linux terminal or shell environment and also can be used on Windows too. The ARP command is used to manage the ARP cache, which is a mapping between IP addresses and MAC addresses, helping in the communication between devices on a local network. To view the ARP cache, use the command ARP-A. To add or modify ARP entries, you can use the ARP command. It can also be followed by options like -S for static entries, specifying the IP and MAC address, and -D to delete an entry. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, make sure to subscribe to this channel so you won't miss any new videos. So we're all set. We have a companion guide, we have VirtualBox with our virtual machines running. I have pfSense. Let's go ahead and click on show so that way that can come up here. I also have Kali Linux as my offensive security. I'm actually going to bring Ubuntu up first. You'll see why in a moment. I have Ubuntu running here. And then Kali Linux is going to be put up on this spot here. And I'm just going to get rid of VirtualBox. And that way we can have all of our VMs on top. And again, we have Kali Linux here. We have Ubuntu here. We also have pfSense. And this is what our document looks like in terms of the map. So Kali Linux is here. I'm going to verify a few things while I'm at it. I'm already in a terminal session. As you know, you can always go into a terminal session by Control-Alt-T. You can find it in the menu option here by looking into terminal emulator, or you can just type in terminal to get into the emulator. I'm already there, so I don't need that. I'm going to get rid of this. In typical fashion, I'm going to make this a little bit bigger so we can see. And I'm going to verify a few things. So I'm going back to the traditional map that we've had here, and I'm just going to do an ifconfig. And the ifconfig is going to give me my interface configurator, and it's going to give me some information here. One, I want to take a look at the IP address, and I see it's the 172.16.1.103, and I have the MAC address, which is 08002753 Charlie Bravo Alpha. Just want to verify these here. I'll do the same thing on the Ubuntu side. I'm going to just get myself into the password here. Just give me a second. So I'm authenticated here. Same deal. I want to go into a terminal session. I'm going to right click, open in terminal. I could have done Control-Alt-T, but we're pretty familiar with that at the moment. I'm going to bring this all the way up to the top here so we can see. This one is a pretty decent size. I can make that a little bit bigger too. So we're just going to make that a little bit bigger, and I'll do IP adder for this one so we can see the same concept here. And once again, I'm looking at the IP address. It's 172.16.1.100, and the MAC address is the 0800272834 Delta. Okay, great. One last check that we want to do to make sure we have everything going here. Let's go to pfSense and make sure that we can do the same thing on pfSense. We'll bring both of the VMs here, and on pfSense we have a shell option, so I can go right to a shell prompt. But before I do, I want you to see this interface here, which is the LAN interface is EM1. So I'm going to go into a shell prompt. I'm going to do ifconfig, and I want the EM1 adapter. The EM1 adapter. And the EM1 adapter is going to show me that I have IP address of 172.16.1.1. Let's bring that up over here. And the MAC address is over here. It's 080027 Bravo 9 Charlie 845, and it corresponds with this MAC address. So I'm confident my virtual machine is lining up nicely with our diagram here. We have everything set up on this side here. So let's go back to the lab. So the lab says go ahead and launch a terminal application with Linux. We did that already. And it says go ahead and do an ARP command. I'm going to clear this for a little bit so you can see. I'm expecting to have a clear ARP cache here. So the ARP is empty. So it's time for us to go back to our diagram and spend a little bit of time about the OSI later and talk about the who is. So this is what our diagram looks like. We're going to add the OSI later. So all people seem to need data processing. We're at the network layer here. And here's what happens from an ARP perspective. So we have our Kali Linux device here, 172.16.1.103, and let's just say it wants to ping the router, the 172.16.1.1. These are all logical IP addresses, and we need the MAC address. So what ends up happening here is this Kali Linux device, when it wants to find out the MAC address, it's going to send an ARP request, or a who is. Is going to say who is 172.16.1.1, and the router is going to reply I am 176.16.1.1 and here's my MAC address. So let's see that in action. So the ARP protocol is address resolution protocol. It's empty now. I'm going to go ahead and ping that 172.16.1.1. It's pinging. Simultaneously, behind there was an ARP request said who is 176, and now we're going to look at the ARP cache, and now we see this MAC address has been put in. So that's exactly what the ARP protocol does. It's an address resolution protocol. It maps IP addresses to MAC addresses. Let's clear the screen so we can see that a little bit better. So I have ARP. ARP is going to show me the IP address to the hardware address, and just to make sure that this is clean and we only want to see IP addresses, we can do ARP-N, no name resolution, and we see that in this table we have 172.16.1.1, and this is the MAC address. Let's do the same thing for the Ubuntu machine. I'm going to ping 172.16.1.100. So essentially what's happening on the back end when I hit enter, the Kali Linux device is going to say who is 172.16.1.100. The Ubuntu machine is going to say I am with this MAC address 0800272834 delta. It's going to be this MAC address here, and let's see if that's true. We'll go ahead and ping. Let a couple of packets go through. We stop the ping. We look at the ARP, and here we have the Ubuntu machine with this MAC address. So great. Let's go back to our companion guide and let's do some housekeeping. We have the terminal session. We did that. We ran ARP, and this was a word about the OSI layer. So you can see as you're going down the stack, when you get from layer 3 to layer 2, we need to do address resolution from an IP to a MAC address. That's exactly what the ARP protocol does. So I'm going to check this off. And we also saw what ARP-N looks like, which is doing an ARP without the name resolution so you can get pure IPs. Okay, so let's go ahead and take a look and observe the output. So I'm going to clear these screens here so that way they're not too cluttered. And we're going to go back to the Linux, and clear its screen there. And let's go ahead and just do an ARP and take a peek. So it's pretty self-explanatory. The address, this is the IP address. It tells us what the hardware type is. It's an Ethernet hardware. So it thinks it has a cable connected to it to a network interface card. This is the MAC address of that Ethernet card for 1.100, which happens to be the Ubuntu machine. If we want to see that again, I'll just do an if config down here. And this is showing me 172.16.1. This is its Ethernet address. This is how we find the Ubuntu machine on the local area network. Flag tell me that it's complete. The iFace is that it's coming out of the F0 interface of the Kali Linux box. Same thing with the pfSense. We have the information here. We know that this is the IP address for the router. If we want to see that in full, We go ahead and do ARP-N, and we see that is the IP address of the router. So this is looking pretty good. So let's do some housekeeping, and we'll continue with a couple of other commands that we want to see here. So I'll clear this here, and we can do an ARP ping. So there's another command that we can use, which is rather than pinging, we can ARP directly. So we can do ARP ing, ARP ping, and I'm going to ping the IP address of the router 172.16.1.1, and it's going to return, well, I got to run it as root, as we always know. We also want to make sure that we're running in regular user mode, and if we need to escalate privileges, we can do that with the sudo command. I'll go ahead and hit enter, put in the password for Kali, and we see that when I run the ARP ping or the ARP ping, I'm doing an address resolution protocol or an ARP request. And what's happening is this IP address is giving me the MAC address. So if we go back to our diagram, I'm ARP pinging this interface. Let's do it on this one without the OSI layer. I'm pinging this interface 172.16.1.1, and it's reading back and giving me this MAC address. Good. I'll kill that. I can do the same thing with the Ubuntu machine, and with the ARP ping command, I can do not only the Ubuntu, which is this device down here. I can only send, let's say, only 4 if I wanted to, just 4 packets. That's too many. You got to do the -C for the count. Sometimes I forget that. So we're going to say sudo ARP ping the Ubuntu machine. I'm expecting to see this MAC address, and I only want to send 4 ARP requests. And sure enough, it's going to send the 4. It stops. It says 4 packets transmitted, 4 packets received, and we have the MAC address of the Niner Delta. So this is ARP ping, and this is another way of sending an ARP request and getting an ARP reply. Address resolution is going to map IP addresses to hardware. So we just do an ARP-N without the name resolution, and I can do an ARP-A to see everything, all of the addresses, and we can also just do that, and it'll give me everything that I need on all the interfaces. I only have one interface. Okay, so this is looking good. So let's say we wanted to, and I'm going to just do the housekeeping, make sure this is all done. Let's say we wanted to add a new device. So here we are at this layer here, and we have the OSI layer. Let's say I wanted to introduce this machine here. So I have a Windows 10 machine, and I happen to know the IP address, and I happen to know the MAC address. I don't have to wait for the ARP request, ARP reply. I can make a static entry, similar to what we've done in the previous exercise with the static route. We can do a static ARP entry. So we'll go back to the lab here, and I'm going to do this on the Kali side. I'm going to clear the screen on the Kali side. I'm going to run the ARP command so we can see that. You can see that the ARP cache has what it needs there. Let's just do it with a -N so we can just see all of the IP addresses. And I'm going to make a static entry here. So essentially, I'm going to type this command into the Kali Linux side. Okay, so I have my command. It's sudo ARP -S for a static entry. I'm putting in this IP address, and I already know the MAC address, so I'll hit enter, and it goes in. And let's go ahead and take a look at the ARP cache now and see what happens. So here we have an example of a manual entry, a static entry, and the M means that it was merged. It's completed record, and it was merged into the table. In other words, we added it manually. I'll do that again. Let me clear the screen so we have a little bit more real estate. I'm going to up arrow and do that again for, let's just say, a fictitious one. So we say 130. So we can go ahead and make another entry. And for argument's sake, we're just making up these numbers for now. And I'm going to put in the command and update it in a moment. Okay, so I essentially did the same thing. I added another entry here. We didn't hit enter yet. I'm adding 1.130 with a MAC address of 30 on the back end. Let's take a look at the ARP cache. So we need to just add those again just to make sure everything is nice and clean. So we have that one in there, and I'm just going to make this a little different. We don't want duplicate MACs, so we're going to make this one 130, and this one's going to be 20. And the idea is to just give you illustrations of a static entry. So now we have our static entries, and that's because we were using this command here. So it's sudo ARP -s is for static entry. And when you see the M, it means that it was merged into the record or added manually. And these were done here. So you can see how that works. Let's go ahead and clear. And as in typical fashion, we always want to know how to do the reverse of a command. So I'm going to bring that up from the history. And I'm going to, instead of a -s for static, we're going to do a tac D for delete. I want to get rid of the MAC address here. I can do Control K to kill the end of this line. And that is gone. To verify, I do an ARP. Excellent. We'll do the same thing with the 120. And we'll do an ARP to verify. And the ARP cache is cleared again of those static entries. So let's do some housekeeping on this side. We saw how we can actually do a static entry with sudo ARP -s. Sudo ARP -d deletes it. And this is how we can manage the ARP cache manually in Kali Linux or Ubuntu Linux, and for the purpose of the CompTIA exam. So I'm going to clear my screen on the Kali side here. And let's talk briefly about an on-path attack or a man-in-the-middle attack called ARP poisoning. Now before I go further here, let me just bring this up here because this is very important, especially as we get into offensive security. Please be aware that ARP spoofing is not only unethical, but may also be illegal in many jurisdictions. Engaging in such activities can lead to serious legal consequences. It's essential to use your knowledge responsibly and for legitimate purposes, such as ethical hacking within controlled environments with explicit permission. This is important. This is why we spent a lot of time setting up our own environment here in a virtual machine so we can practice in peace under a cover of darkness. But you can't do this on machines that you don't own or have permission to do so. So let me explain this a little bit more before we get into the actual ARP spoofing and get back to our diagram here. So we have the Kali Linux device here. So it has its interface. So we have ifconfig. It has its IP address and its MAC address here. We have the Ubuntu machine, which let me authenticate into that. And while that's happening, we see it has its interface 172.16.100 and it has a MAC address of 9D. And then we also verified what the pfSense here is. What I'm going to do is poison the Ubuntu's machine's ARP cache. Now remember, this is its MAC address and it's written down here. So I'm going to clear its ARP cache. I'm just going to display it. And we're going to do it with a tac N so you can actually see these IP addresses. So we'll clear and we'll ARP -N and it's clear. And I'm going to fool this ARP cache so that way it thinks that I am the router. So the next time the Ubuntu machine says, hey, where is 170.16.1.1? I'm going to reply that I'm 176.16.1.1, although I'm really sitting here at 100. So we'll clear the screen here. And I'm going to go ahead and do an ARP spoof command. Okay, before I actually execute the command, so here's what's happening here. I'm spoofing. So essentially I'm going to hit this target machine, which is the Ubuntu machine here, sitting at 100. And I'm going to tell it that I am now the router. Although there is a router here, I'm basically telling it that I'm the router, and we're going to see this in its ARP cache. So I hit enter on the Kali Linux side, and after some point, it tells me that 9D and 45 are both reporting as 176.1.1. So over here in 45, we have that. Let's take a look at its ARP cache now, the Ubuntu machine, because that is the target. And we're going to look at the ARP and give that a moment. And now we see it has been poisoned. It thinks that my machine, the 103, 172.16.1.103, can be found at this MAC address, which is my MAC address here. So it thinks the gateway can be found here, and it also thinks the gateway can be found here. So we are now poisoning it here. In other words, this device will now think that I am the router. It's going to send information, at least layer 2 information, over to my Kali Linux box. This is what we call a man-in-the-middle attack. I'm going to stop poisoning the ARP cache. So we'll stop the ARP spoofing on the Kali side. And at this point here, we'll give it a little time to catch up. And we'll take a look and give it some time. We can also just clear all the entries. I just want to make sure this is clear on this side here. Let's go ahead and clear the cache. This is a good time to do that. First, I'll just look at the ARP cache here, get a nice fresh one, and it should be getting back to normal any second now. So to clear the cache, we're going to do sudo ARP -D for all. It's going to clear that. Let's do that a few more times. Just make sure we have everything clear. And now we're going to ARP, and now everything is back to normal. This Ubuntu machine can now see the pfSense router is on 45, and it sees my machine in Bravo Alpha. And now we know we are back to normal. Just wanted to let you know about on-path attacks. We discussed this in the CompTIA exam and also in the lecture notes. It's also ARP poisoning. You can do that with a variety of tools. We happen to use ARP spoof. There are a number of things you can do to prevent ARP spoofing. So one of them is you can do static entries and make sure that there are just specific paths from IP to MAC address. There's also ARP spoof detection software that you can implement on your networks. And also many Cisco routers and other routers too have dynamic ARP inspection tools to mitigate against ARP poisoning and ARP spoofing. And there's also port security, where with a sticky port on like a Cisco switch or anything else for that matter, only a few or only one MAC address can actually connect to a port. So let's do our homework here. I'm going to minimize this, bring this up a little bit so we have more room because we're almost at the end. So you see here, if we want to, we can flush the cache. Let's go ahead and take a look at the cache. The cache is what we see here, which is the router, and this is the Ubuntu machine. If I want to get rid of them, I can use the sudo ARP -D. We saw that before, so with sudo ARP, it's going to be -D to delete, and all entries. It says it couldn't find that because I mistyped it, so it's ARP. Do that again a few times. Let's take a look at the ARP cache. It's still persistent. If that gives you a problem, you can use this entire command here to truly flush the cache, and let's give that a whirl. Okay, so this command is a little bit more robust. It says round 1, deleting 2 entries, flush is complete after round 1. I'm just going to do it again. Nothing to flush. Let's see if that's true. And we're back to square one where we started at the beginning of the companion guide, where we had a clean ARP cache. And if something needs to find out, it can always do a whois or an ARP ping. We saw that. For housekeeping, I'm going to tick that off. And as always, if you want to know a little bit more about the ARP command, you can always do ARP tac help. That'll give you some of the options here, and we explored some of them. Or if you want more robust information, you can use the manual page, which is manual ARP, and that'll give you some information as well. Last but not least, the reason why we discuss this is not only for security reasons in the real world, but it's also on the exam. You may see something like this. What command produced the following output? We know it's not ifconfig, we know it's not traceroute, we know it's not the DH client because we did all of these in the previous section. We know it's not route N, it is ARP. So once again, excellent job. Remember to exercise caution when modifying or deleting the ARP entries. It can affect network traffic. And in the next class, we'll talk about H-Ping 3. I'll see you then.